16. A stone on the end of a string is whirled clockwise at constant speed in a horizontal circle, as shown in the diagram below. So this stone is getting whipped around in a circle. Which pair of arrows best represents the directions of the stone's velocity, v, and acceleration, a, at the position shown? So the first thing I want to talk about here is if they want us to draw the vector arrows for the velocity and the acceleration, but it says this thing is traveling at constant speed. So how can that be? I thought if something was moving at constant speed that meant there is no acceleration. So why would there be any vector at all? Well, we have to remember that with vectors, we're not just dealing with magnitude, right? Vectors have magnitude and they also have direction. So this acceleration is not causing a change in the magnitude of the velocity or the speed. It's causing a change in the direction of the velocity. So that's a key distinction to make. So now we can talk about the velocity. So this is centripetal motion, right? It's traveling in a circle, and at any moment if the string were to break or the stone were to fly out of orbit, so to speak, it would move tangential to its current it would move tangential to the circle. So currently its velocity is should be straight down if it were to be released at that point. So if that's the direction of the velocity, that satisfies 1, 3, and 4. We can eliminate choice 2. Now what about the acceleration? The acceleration is not changing the speed or the magnitude of the velocity. It's serving only to affect the direction. So if the direction of the velocity is straight down at this point, at some point in the future, suppose it's right here at the bottom, the velocity is going to be to the left. So how does the velocity vector get from being straight down to being to the left? Well, it's getting turned at every moment. Let's do another one. At every intermediate moment, its velocity is getting turned little by little. And what's doing that? The acceleration is doing that. And the acceleration in centripetal motion is always inward. So at this moment the acceleration is acting like that, at this moment the acceleration is acting like that, and at this moment the acceleration is acting straight up. So in summary, the acceleration is always inward. And that's a constant theme that comes up when talking about centripetal acceleration. The acceleration is always directed inward. So at this particular moment when the stone is here, the inward acceleration is to the left, and 4 is the only choice that fits.